So in the last class, we have ended the prevent rusting of iron and the methods how to prevent rusting. Now we have aluminium's apparent unreactivity. So aluminium, if you look in the reactivity series, how many of you memorize the reactivity series? This one. Okay, do it as soon as possible. Okay. So if you see in that reactivity series, there is a potassium, then sodium, calcium, magnesium, aluminium. So aluminium is among the ones which are more reactive, most reactive one. But when aluminium undergo a reaction with the oxygen or water, it will form a layer of oxide on its surface like this, if you see. So when that layer of oxide is formed, which is Al2O3, the aluminium metal which is inside over here in this region is actually got protected from water and oxygen, and further reaction stops. So apparently it shows that the reaction does not occur, and it is because that this aluminum oxide is water insoluble, doesn't dissolve in water, and do not let the water or oxygen to react further with aluminium. Is this clear? Yes. Yes, Khatija and Sania?
Sir, can you please explain once again because I was not hearing you properly?
Okay. See, when the aluminum start reacting, the aluminum oxide is formed, but that aluminum oxide doesn't flakes off from the surface as iron oxide was doing in the rust. So as it doesn't flakes off and it doesn't gets removed from the surface, so there is a protective layer formed on the surface which protects the inner aluminum atoms from oxygen and water, and further reaction stops. So it looks that the reaction does not occur. So that's why we call apparent unreactivity with oxygen and water. Now
Okay.
is it clear?
Yes.
Sania, is it clear to you as well?
Sir,
Yes, Khatija.
sir, I want to ask, you said that the aluminum will react with oxygen and water, but in the equation only oxygen is there.
Yes, the equation is with, in our syllabus, the equation is with oxygen only.
Okay, and sir, one last question, that what is mean by flake off?
Flake
Only
off means, like, if you recall, when the rust is formed, the solid rust flakes off or get removed from the surface, and the inner new metal become exposed to the atmosphere, right?
Yes.
That's called flakes off.
Okay. Thank you.
Okay. Is this clear? Everybody is done?
Yes.
Yes, Sania?
Yes, sir, done.
Okay. So here we have ended the chapter. Now we are going to do few past paper questions. And after those past paper questions, in the next coming class, we will be going to start redox, and make sure when we are doing redox, you guys have periodic table with you. And do memorize reactivity series as soon as possible, okay? Okay. Now have a look at this question. Magnesium reacts with steam. Name the product of this reaction. Okay. So magnesium is a metal. And when metal reacts with steam, what are our products? Yes, Sani, Manali. You are not revising? Just check. Yes, Sania and Khatija. Yes, what were the products when metal and steam react? Good, metal oxide and hydrogen. So here in this case, which metal is we are allowing to react with steam? Yes.
Sir, we have to make formula for this, right?
No, they are asking for the name. So just tell me which metal we are with steam.
Okay, sir.
In question, which metal is written?
Magnesium.
Magnesium. So if metal is giving you a metal oxide with steam, so in this case, it will be
Magnesium oxide.
magnesium oxide and
Hydrogen.
hydrogen. Magnesium oxide and hydrogen. Is this understandable?
Yes.
We don't need the formula because they didn't ask. Now in the next part, see what they ask. When calcium reacts with cold water, write the equation for this reaction. So what are the products when a calcium is also a metal? When metal reacts with water, what are the products?
Metal oxide and
No,
hydrogen.
not metal oxide. It's cold water. And with steam, we are getting metal oxide. Look at the reaction with cold water. When metal reacts with cold water, what are the products? You guys have practiced the equations for these reactions as well, right? Yes, metal with cold water. Metal hydroxide will form. So in this case, if calcium is reacting with cold water, then calcium hydroxide will form and a hydrogen gas. So here we got a hydrogen gas. Now hydroxide, what is the charge on hydroxide ion?
-1.
-1. And what is the charge on calcium ion?
2 plus.
2 plus. Yes. Then what will be the formula now?
CaOH2.
CaOH.
OH twice. See, now the equation is formed, but equation is not balanced.
Yes.
So how we will balance? How many hydrogens are over here? 4. Because it's 2 outside the bracket. So I have to put 2 over here to make hydrogens 4. Assalamualaikum Aisha. Molybdenum steel is an extremely hard alloy. Suggest using ideas about metallic structure why molybdenum steel is much harder than pure iron. A label diagram may help your answer. So if we have to show the label diagram, and molybdenum steel is what? Is an alloy. And what is alloy? It's a mixture of more than two or more than two metals. So it means if it's an alloy, there are different size of atoms in it. And due to these different size of atoms, its structure become hard, rigid, and it is very difficult for the layers of atoms to slide. That's make it more harder than a metal, as here they are asking with a pure iron. So how we will answer this? That if it's a pure iron, we can say that pure iron has same size of atoms but molybdenum alloy has different size of atoms. So the layers of atoms cannot slide or difficult to slide, make it more hard. आप लोग yes, hard copy. Is this clear?
Yes, sir.
Yes, Aisha and Sania. Yes, Sania. And if I make the structure of iron, so in iron, all the atoms are of same kind, right? So if all the atoms are of same size, so see there,
Yes, sir.
when we apply the force, the layers can slide over each other. And here, when I, for example, apply force over here, this layer cannot be slided because of this bigger sizes of atom. So that's make it a difficult to slide, and that's make molybdenum steel harder than pure iron. Is this clear?
Yes.
Yes, Aisha.
Sir, can you tell me how they cannot slide?
Yes. See,
Because
see, this is a bigger atom, right?
yes,
So see this. If these atoms are of same size, and I apply from a force from the left, for example, so these atoms can be slided like this.
yes.
But here, if I'm applying a force over here from on this layer, so this atom is actually
Bigger.
bigger in two layers. So this atom cannot be slided because these atoms are not experiencing any force, right?
It will not let others to pass.
Yeah.
Okay.
So these atoms does not let this one to slide, and that's make the alloys harder than metals. Is this clear?
Yes, sir. Clear. Thank you.
Aisha, did you understand?
Yes, sir.
Okay. Now, have a look over here. Okay. See, sodium is a metal. Okay. If you see in the periodic table, you will find in group 1. It's a group 1 metal, okay? And group 1 metals are considered as soft metals. Normally, we know the structure of metals, they are very hard, right? So, state 2 physical properties of sodium which are different from most other metals. So, it's a soft metal. What do you know about the melting points of metals? Do the metals have a low melting boiling point or high?
Hi.
High. But as it's a soft metal, it has low melting and boiling point. Is this clear?
Yes.
Okay. Now, compare the electronic configuration of sodium. Complete the electronic configuration of sodium. Show all electrons. So see how you will attempt this kind of a question. You are going to look into the periodic table. See in the key, that is atomic number, and atomic number refers to the number of electrons in the atom. So the atomic number of sodium is
11.
11. So it means sodium have 11 electrons,
Yes.
right? So these 11 electrons, if sodium have 11 electrons, these 11 electrons are distributed like this in the first shell. It got 2 electrons, then 8 in the second shell, and 1 in the last shell. So that's how we will do. We will put 2 electrons in the first shell, then 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second shell, And in the third shell, we make 1 electron. Is this clear?
Yes.
Yes, sir.
Okay. Yes, Aisha, did you understand?
Yes, sir.
Okay, now construct the equation for the reaction of iron 3 oxide with zinc. The products are zinc oxide and iron. See, if you read the question, they have provided you everything. They are provided you which substances are reacting with each other.
Iron oxide and zinc.
Which iron oxide? Iron 3 oxide, and they have provided you its formula and zinc. See, construct the equation for the reaction of iron 3 oxide with zinc. It means these two are going to be the reactant in the chemical equation. So when I'm going to make the chemical equation, I'm going to put these two on the left side of the equation like this. Is this clear?
Yes.
Okay. Now, the products are zinc oxide, ZnO, and iron. So they have given you the products as well. So on the right side of the equation, you have to mention zinc oxide and iron. Is this clear?
Yes.
Okay. Now,
Yes, sir.
is my equation is balanced? No.
No.
How we will balance it? Two Fe, very good. 2 before Fe. Now iron is balanced. On both sides, we have got 2 atoms of iron. Three ZnO, 3 before ZnO, because there are 3 oxygen over here. So I have to make 3 oxygen over here as well. So when I put a 3 over here, that makes this zinc as well 3. So 3 before Zn. Now there are 2 iron atoms over here. There are 2 iron atoms over here. They are balanced. There are 3 atoms of oxygen over here. There are 3 oxygen of atoms over here. This is balanced. There are 3 atoms of zinc over here. There are 3 atoms of zinc over here. This is also balanced. Is this clear?
Yes, sir.
Okay.
Yes, sir. Yes.
Yes. Zinc oxide reacted with dilute sulfuric acid to form aqueous zinc sulfate. Construct the equation. Okay. You have to remember the formula of sulfuric acid. It is H2SO4. And zinc oxide, the formula is given in the previous part. It is ZnO. So ZnO H2SO4 to form zinc sulfate. So zinc sulfate is our product, right? ZnSO4. Why is it ZnSO4? Because zinc have 2 positive charge and sulfate have 2 negative charge. So we just join them. Okay. So is there anything which is present on the reactant side? And we didn't mention over here hydrogen and this oxygen as well. So there are how many hydrogens? And there is how many oxygen? So when these hydrogen and oxygen meet, what react, what will form?
Water.
Water, H2O. Is it clear? Yes, Sania
Yes.
and Aisha, if you guys have any doubt, do ask, please. Is it clear? Okay. Now, this is for you. You have to make the equation. Do read it carefully and then make the equation. Okay, Sanya.
Okay, Allah Hafiz, sir.
Allah Hafiz. Yes, Aisha, Khatija.
Yes, sir, I'm making.
Okay.
Yes, sir.
You have to make this equation and WhatsApp me.
Okay.
Read it. What they have seen. Chromium. So what are we? There is no need to look at it. They are saying molten chromium reacts with steam. So what are the reactants? No, CrO2O3 is chromium trioxide. Yes. And what is steam? Steam is the gaseous form of water. So H2O. And what is this? See, to form chromium trioxide Cr2O3, so it means it is going to be your. Yes. Okay, Khadija, send me the equation. Yes, Aisha, did you make it? Yes. These two are there. What two things are reacting? Yes. What two things are reacting? No, chromium oxide. To form chromium oxide, it means chromium oxide is common. Molten chromium and no, hydrogen is your product. And steam. So our reactants are molten chromium and steam. Yes, Aisha, did you make the equation? So, see, molten chromium, which means chromium in the molten state, reacts with steam. Steam means H2O in a vapor or gaseous form to form chromium oxide and hydrogen. To form, so the things that are forming are the products. So, and the things which are reacting are the reactants. So I am going to write chromium molten and water vapors, H2O in a gas state on the reactant side, and on the product side I am going to write Cr2O3 and hydrogen. Is my equation is balanced?
No.
So how will balance it?
We will place 4 at chromium on the right side, sorry, left side,
What? Okay.
and yes, and 6 on the steam,
Okay.
and in chromium oxide 2,
Okay.
and in hydrogen 6.
Yes. Okay, but can't we, Sanya, the more way is this? This is not wrong, this is correct as well. But see, how many chromium are over here on the right side? 2. So I will put 2 over here. How many oxygens over here? 3 over here. That makes these hydrogen 6. So I will put a 3 over here. Right?
Yes.
The equation that is also correct. But that is the simplest form of the balance equation. Aisha, did you understand? Okay. Now, you guys have to make these two equations on. Okay. Read the question carefully. In both the equations, they have provided you what are the reactants and what are the product. Whenever examiners say it is reacting with air, so it means it is reacting with oxygen in the air. So do complete it and just give me 5 minutes. I will be offering the prayers and be back in 5 minutes. Okay. Understood. Yes. Who are done with the equations? C. CuFeS2 is heated in air. It means our one reactant is CuFeS2 and the other reactant is oxygen. Now read the copper 2 oxide, iron 3 oxide and sulfur dioxide are formed. So copper 2 oxide, copper have a 2 plus charge, oxide have a 2 minus charge. So its formula is going to be CuO, right? Copper 2 oxide is formed. Iron have a 3 plus ion over here because they have mentioned iron 3. And oxide have a 2 minus charge. So what will be the formula?
Fe2O3.
Fe2O3, very good. Iron 3 oxide and sulfur dioxide. Di means 2.
SO2.
As we say carbon dioxide, it's CO2, right? So sulfur dioxide must be SO2. Now, I have to balance the equation. So see, this is how we make the equations. Now, how many iron are over here?
2.
2. And on the reactant, how many irons we have? 1. So what I'm going to do, I'm going to put a 2 over here. If I put a 2 over here, that makes copper 2 as well. So I will put a 2 over here. That makes sulfur 4. Very good. So we are going to put a 4 over here. Now, how many oxygens are over here? Check again. How many oxygens are over here?
13.
2. How many over here? 3 makes it
3.
5. And 4 times 2? 8. So 8 plus 3 plus 2. Very good. Khatija, 13 oxygens. And how many oxygens over here? 2 only.
2.
So what I will do, if I put a 13 over 2, then it becomes 13. Why? Because whatever the number that we always put before is multiplied by this value. So if I multiply 13 over 2 by 2, these two are going to cancel out and we are left with. So we will put a 13 over 2 over here. Now the equation is balanced. Is this clear?
Yes.
Yes, Aisha? Now, copper 2 oxide can be reduced by heating with carbon. So it means copper 2 oxide is reacting with
Carbon.
carbon, and copper 2 oxide, we just figure out the formula in the previous part, it's CuO, and it is reacting with
Carbon.
to form copper. So it means we are going to get Cu only. So when copper and oxygen reacts, what is formed?
Carbon monoxide.
Carbon dioxide. So it's CO2. Now see, we have a 2 oxygen over here. So I'm going to put 2 over here. And that makes copper 2. So I will put 2 over here. Equation is balanced.
Sir, copper monoxide नहीं बनेगा.
Sorry.
Copper monoxide नहीं बनेगा.
Why?
Because in the equation जब copper हो गया तो सिर्फ एक O बचा और एक C बचा.
Yeah, but usually when a carbon and oxygen reacts, if they didn't provided you any condition, then always you will make carbon dioxide, and on the basis of carbon dioxide you will balance these.
Sir, can you please explain this again?
Yeah, see, oxygen and carbon is left, right?
Yes.
Oxygen and carbon left when the copper is formed. So whenever carbon and oxygen reacts, we always get carbon dioxide unless they have provided you some specific information to tell you that there is a formation of carbon monoxide. Otherwise, we do not consider formation of carbon monoxide. Always carbon dioxide forms.
Okay.
So there is no specific conditions or specific information which is indicating that there is any unusual product, because carbon monoxide is actually an unusual product.
Okay, sir.
Okay. Yes, Aisha, did you understand? Yes, Aisha. Okay. Now have a look at this. For these kind of a reaction, you have to remember or memorize the reactivity series. Let me write over here. First one is potassium, then sodium, then calcium, then magnesium, then aluminium, then zinc, then iron, then lead, and then we have a non-metal over here, hydrogen, then we have a copper, then we have a silver, then we have a gold, and then we have a platinum. You have to remember the sequence, and in the sequence we have discussed in the previous class that the metals reactivity decreases as we move down. A student heated different mixtures of a metal and metal oxides. The table shows this. And what we have discussed, the one which is above can displaces the one which is below from its compound, right? So here see the compound. In compound, which metal is there? Iron and zinc as a metal. Reaction is occurring. So it means zinc is displacing the iron. So zinc is more reactive. Okay. When lead to oxide and iron is placed, reaction is taking place.
Yes.
So it means iron is displacing the lead. So from here, from this, what we have concluded that zinc is going to be above and iron is going to be lower in reactivity. Here, iron is displacing lead. So it means lead must be lower in reactivity. Then this also indicating that this, because reaction is occurring, so zinc is displacing the lead, so zinc must be above lead, and that's what we have concluded over here on this side. Now zinc is reacting with magnesium oxide and reaction, so it means magnesium is more reactive than zinc, so magnesium must be over here. That's why this reaction does not occur. Is this clear?
Yes.
So predict the order of the reactivity of metals: iron, lead, magnesium, and zinc. So what we understood from this table, what we have concluded, which one is the most reactive?
Magnesium.
Which one is most reactive?
Magnesium.
Magnesium. Good. Then, okay, they have asked you the least reactive. So which one is least reactive? Lead. Then
Iron.
iron. Then zinc.
Zinc.
And most
Magnesium.
magnesium. Okay. Construct the equation for the reaction of iron 3 oxide with zinc. The products are zinc oxide and iron. I think we just did this.
Yes.
Okay, now have look over here. Aluminium is high in reactivity series but does not appear to react with either water or acids. Explain why aluminium appears to be unreactive. So that's what we have discussed in the start of today's class. Why is it so? Aluminium forms
Aluminum oxide.
Layer of its oxide or layer of aluminum oxide, both are correct, which act as a barrier for water and acid. Is this clear? Why aluminum is used in manufacture of aircraft? Who is going to tell me this reason? We have discussed this in the first class of the metals.
Because it is lighter.
It is
Lighter.
lighter. So the better term or the appropriate term we use is that it has lower density. That's why we make aircraft from it, so it have a lower density, so it can easily be able to fly because of low density. Is this clear?
Yes.
Okay. Only one naturally occurring isotope of aluminium is known. State the number of protons, neutrons in this isotope of aluminium. So if there is one isotope, so we can take the help from the periodic table. It's 13 and 27, right? So 13 is the proton number and 27 is the nucleon
Neutron.
number. So how you will find the neutrons?
Minus.
Very good. 27 minus 13 gives us 14. Is this clear? Okay. So in the next class, we are going to start the redox reaction. Please make sure that all of you have periodic table with you. Okay.
Okay, sir. I have a question.
Yeah.
That in this question they have asked about the isotope.
Yeah.
So in isotope, the neutron number is different as compared to the atom of that.
The
atom.
other isotope, right? The
Yes.
neutron numbers are different in the isotopic atoms, right?
Yes, yes.
But here they say that that is only one isotope.
Okay.
It means it's that's it. There is nothing else. There is no other isotope of aluminium but this only, which we took it from the periodic table.
Okay, okay.
Okay. So see you everyone inshallah in the next class. Take care. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.